Here is a lightning-fast tutorial on how to set up a data pipeline using Streamdal's code-native data pipeline platform. For the purpose of the walkthrough, I'll assume that you've already installed the Streamdal platform. If not, head over to the GitHub repo here, and you'll see in the Getting Started section a curl bash installer, which will fire it up locally using Docker Compose. Or if you want to install it in your infra or your cloud, head over to docs install and you'll see a variety of ways to do that here. Before we get started, the platform consists of two main components, the console and a server. The console is the UI or GUI that allows you to set up and manage your pipelines and visualize your pipeline data. And there's a server, which, among other things, brokers communication between the console and your code using our SDKs or our shims, and it ships the pipelines in the form of WASM for your code to execute. When you first fire up the platform, you'll notice that the console is empty. This just means that no application has yet made a pipeline request. So the first thing we need to do to get started is to install an SDK and make a pipeline request. Demonstrate a pipeline request using the Node SDK, but we also have SDKs for Python and Go and a variety of shims. So for Node SDK, npm install Streamdal Node SDK, and then all you need for a pipeline request is a couple of bits of configuration. The first being the main configuration that tells the SDK where the server lives and how to contact it. One critical bit to call out here is the name of the service. This is what the main application grouping will show up as in your console. And then in addition to the server configurations, you need to send it an audience. And an audience is just our terminology to describe the actual read or write operation that you want to attach your pipeline request to. The audiences consist of a few properties. You can see the service name here matches the service name that we provided to the server config. And also component name corresponds to your data source or destination. Here for an event source system, we're using Kafka, but this could be Postgres or MySQL if you're dealing with a database. Operation type is always either consumer or producer, indicating read or write, and then the operation name is simply a human-friendly description of that. Any particular service can have any number of audiences. An example might be like an order service that has a collection operation, a fulfillment operation, and a shipping operation, or user onboarding, or something like that. As far as the actual pipeline processing is concerned, it really is once you've constructed those two configuration components, the server and the audience, then it's just an instantiation or construction of the server, and then a line of code to call the pipeline processor. Let's fire up a Node app so we can make an example process pipeline request and head into the console and set up a pipeline. If you look in the Node app, the Node SDK itself, you'll see there's an examples directory with a couple of very simple examples, one for common JS projects and one for ES projects that use ES modules. We're going to use a slightly more complicated example. In the sandbox, I've set up a variety of semi-real world looking pipeline requests for billing and key value requests. And we're going to use those today to set up our pipelines. Over to the Node SDK sandbox, which I have checked out locally. Here I have set up a billing example, which will load three different services: a billing service, a sign-up service, and a welcome service. For each service, we'll load up a variety of sample data and then run it at random intervals to simulate real-world data activity. The service configurations are pretty straightforward, like you saw before: billing, sign-up, welcome. And the pipeline requests, there's a little bit of helper code here to run these at intervals and to add a lot of logging, but the pipeline process request itself is, like you saw before, simple one line and then grabbing some result data, including errors if they happened and statuses for any steps that might be in the pipeline. Let's fire up the sandbox and make some pipeline requests. I have the console running locally, I have the server running locally, and the Node SDK checked out with our sandbox, which I'll run. When you first run the sandbox, it will reach out and register itself with the server. There are no pipelines set up yet in the console, so it won't pull down any pipeline WASM, but the act of registering will let the console know about our services. So we can now go into the console and manage our services and set up pipelines. Even before we set up our pipelines, you'll notice that the console has arranged our services in an interactive visualization that gives us some meaningful insights into how the data is moving through our system. When we make our pipeline process requests, even though there is no pipeline yet to run on the data, we still send up metrics about the data that's moving through those pipeline requests, so you can have an idea of how, like, the throughput of your various of data through your various services. So you can see here we have information about the bytes and the number of messages processed. In addition to that, if you select on any given operation, we have the ability to ask the SDK to send up the actual data so that we can view it. Like, we call this tail. It's just an ability to sort of sample and peek at the data that's moving through your system. So let's just take a look at our consumer on our billing service and request a tail. And sure enough, you can see about a message a second or so moving through the system. It's important to note that when you're making a pipeline process request, data is not sent to the server. Only if you go into the console and ask for a tail will the data be sent up. Let's create a pipeline and attach it to one of our operations. We'll stop our tail here. Let's have a look at our emailer. For the sake of this, we'll assume that our email producer is writing emails out to some service that we don't want to expose the email to. So let's just have a look at the data real quick in tail, give us an idea of the shape. And we can pause that. And sure enough, we have a recipient. Let's say we would like this to be, this is PII, and we don't want it to enter the system that we're writing to here. We can attach a pipeline to mask it or remove it. Let's create a new pipeline. Let's call this mask email pipeline. Let's add a step. Recipient, let's see if it's there first. Detective step means what it says. It's able to detect if a field exists. We'll look for recipient. We'll see if it has the field. If it does, we'll add a second step that masks it. So if we're going to change the data, that's called a transform. There's a variety of operations under here. We'll start with mask. We want to mask our recipient field. And for every pipeline step that we add, we can have a variety of success or failure conditions, which we'll talk more about later. For now, we'll leave them blank. Save that. After the pipeline is saved, we can attach it to the current operation under the pipelines dialog. Choose attach, and that attachment is immediately sent by the server down to the Node SDK, which will begin processing pipelines. So let's just tail now and see what we've got. And sure enough, you can see the recipient is now being masked in our code. We have a before and after, so we'll pause that. You can see the data that was sent into the process pipeline request had an unmasked recipient. The WASM-based mask recipient pipeline rule was executed in the SDK, and the result that came out of the process pipeline request was a masked email. Look at a couple of the other pipeline options before we call it a day. Let's edit our pipeline. Let's take a look at the recipient step. We were previously masking, but you can also delete the field altogether. You can replace it with a given value. You can truncate it. You can extract. You can truncate it based on a percentage or a fixed character length. You can extract given data. This is an interesting one. If say we only wanted the recipient to come out of that pipeline, then this would accomplish that. Let's just try it. Sure enough, all the other data is dropped and we just get our recipient. To detects and transforms, there are also a couple of other pipeline step types. You can actually load up key values using an API in the server and check whether those values exist either statically or dynamically in your code and take actions depending on that. And there is also a schema validation type step where you can provide a JSON schema and it will tell you whether or not the data that's coming through is valid. You can see here that we actually will infer from your data what your JSON schema is. So you could simply supply that schema to a pipeline step and determine if that is valid data according to your schema.